This is the conic section part 3. Recall the hyperbola is a graph with two branches open outward, right? So here I have horizontal transverse axis, okay? So for that one, we have a formula here, x minus h squared over a squared minus 1 minus k squared over b squared equal 1. Now, if you compare the hyperbola with the ellipse, you see the formula actually look exactly the same except for the minus signs in between. So if you have the equations earlier when you have, say, x minus 2 squared over 4, then plus y minus 1 squared over 2 equal 1. Okay. Now we know that this is the ellipse, right? So here's an example of an ellipse. Okay, an ellipse. And since 4 is bigger than 2, you would have a horizontal ellipse, or the ellipse with horizontal major axis. If we change the plus sign to the minus sign, okay, so with the very same equation, x minus 2 squared over 4 and y minus 1 squared over 2 equal 1, and if that is a minus sign, then you will have a hyperbola with the horizontal transverse axis. This time the 4 is actually the positive x over this form. Now, the two actually related. If you graph, let's say if you graph the ellipse, okay, then your ellipse will be, say these are the 4 points in your plot. And that's your ellipse there. Okay, then the corresponding equations here with the minus signs will give us the hyperbola. Okay, you see that using pretty much that same rectangle. When you graph the ellipse, we use a rectangle, right? Graph that one. But for the hyperbola, you're gonna draw the axis through the corner, and that'll be the axis of the symmetry, and then that'll be the hyperbola. Yeah. All right. And if you swap the two, so that is, if you swap the sign, you're going to have the y minus 1 squared coming first over 2, and minus x minus 2 squared over 4 equal 1. Then it's going to be, we're going to use the very same rectangles there. But then the hyperbola will be the one that since I switch, you see that one is the y coming first here. So we have a vertical transverse axis, so be this axis here of symmetry, and your hyperbola will be that one, right? So it go through this point as a vertex, and like that. All right. Now again, if you are given in the standard form one of these two, then it's easy to identify the vertices, the foci. But if we are not, for example, here, sketch the graph of the hyperbola whose equation is 4x squared minus y squared equals 16. You see that one is not in standard form yet, but I could make some adjustment or put it in that form. In this case, only x squared and y squared, there's no x and y term. so we don't need to complete the square. All I do is make sure that this right hand side is 1. So we actually divide both sides by 16. Okay, so that will turn into a 1. Let's have a 16. 4 over 16 is 1/4. So you got this, right? So then from here, I can easily identify the H and the K. By the way, looking at this, you see we are in the first form, horizontal transverse axis, and the H in this case is 0 and K is 0, right? The A square is that one, the one that's come first, okay? A square. So the A square is 4 and B square is 16. We no longer require the A's got to be bigger than B as in ellipse. All right, so then you solve, then A will be 2 and B would be 4. Then you're gonna plot the vertex, the center. Okay, so you plot the center first. So these two give us the center at 0, 0. Then we're gonna locate the 4 special points by moving left, right, up, down using these 2 numbers. Okay, so okay, so we got all of these. So I think I have this solved over here. And to figure out the foci, the locations of the foci, you're going to figure out the C using the Pythagorean theorem, C squared equal A squared plus B squared. A squared is 4, B squared is 16. Then you take the root of both sides, solve for C, and we got square root of 20. All right, and then from here, I can sketch the graph of the hyperbola using all the information that we just found. Okay, you're just using the information we have just found. Again, we're going to start with what we will start with the center. Okay, always start with the center first. Okay. Right, so where's the center? Right here, right? The origins is our center in this case. So I have the origin 0. Then you have A is 2. Okay, so again, don't forget that the A is 2 and it's the B. But this is a horizontal. And we have, I think it's the horizontal, yes, so B, the first form here. So here's A, right? So underneath the X, I'm gonna move 2 units to the left, 1, 2, 1, 2. Right, so that'll be your vertex 1. That'll be the vertex 2. Okay, that's a V1 and V2. And then we're gonna move from the origins B1 or B is 4, right? So you're gonna go up 4 and down 4. Now the 2 points here is not on the hyperbola, right? So this point here, that's not on the hyperbola. However, I want to use that to construct the rectangles that help us figure out the asymptotes. Okay, the asymptotes. And so you can draw the asymptotes. Okay, so minus 1, not right. Okay, and then it's the second line. See, that's the line through the corner. Okay, so it's through the corners of the rectangle, and therefore it will go through the center as well. See that? All right. And now again, these two are the vertices. So the hyperbola will be, let's see again, there's an asymptote that will be served as an asymptote. And it goes through the vertex, so it's open left and right. I missed it. I can do a better sketch. Erase it. It's open like this. All right, so that is the hyperbola. And again, the vertex will be at -2, 0, and at 2, 0. If you want to find the foci, right? So the foci this time will be somewhere over here. C, we have calculated this root 20. So root 20 is approximately, I think it's more than 4, right? It's less than 5, so it'll be 4-ish. I'm not sure. So between 4 and 5, that'll be your foci. And so gonna be 1, 2, 3, 4, that's 5. So I'm gonna go 1, 2, 3, 4-ish. So somewhere over here. And you go 1, 2, 3, 4, 5. So somewhere over here. So that's your focus 1. That is the focus 2. And the focus 1 is negative root 20, 0. And that'll be root 20, 0. Right? Now, in these examples, we have we basically put it in a standard form, either hyperbola or parabola, ellipse. In we identify those main points, main features. Okay, especially we are interested in the foci of the conics. Okay. Now, we might have to do it the other way around. The other way around is given these features, okay, some special property that I want you to satisfy, we're going to find the equations of the conic, okay? For example, here, number 1, can you run equations of hyperbola with vertices -3, -4, -3, 6, and the focus at -3, -7. Okay, so first let me plot those points first. Okay, so I draw the Cartesian plane, okay, x and y axis. and identify the vertices at -3, -4, right? So -3, -4. So that's my vertex 1. -3, 6 will be here. So that's vertex 2. The focus is located -3, -7. So it would be down here, right? So this point is my focus 1. Now, without saying the other focus, I know where it's located because of the symmetry, right? So in order to write, so the focus 2 will be actually like 1, 2, 3. I think it's up here. It's down 3. So up 3. So that has to be my focus 2 there. I don't think it did it, but okay. So now, first thing that determines the hyperbola, the equation. We have two forms of hyperbola: the vertical and horizontal transfer axis. You can see that all of these spectral points are on the vertical line. So it is definitely a vertical transfer axis, which is, see this one over here. Okay.